Hi everyone, and welcome to this show and tell about Gemnasium. It's basically an overview, a little workthrough about what is Gemnasium, what is dependency scanning, maybe in general too, trying to highlight a few concepts and give an overview of the architecture we're playing with today to basically help new team member joining, getting up to speed with contributing to that project particularly. So there's an agenda. If you haven't seen that, it's a Google Doc. Let me share that quickly in the chat. You can find that in the Google Calendar invite otherwise. So I shared some materials there, a few links that might be relevant to check. Obviously, the Gemnasium project itself. I'll go ahead and share my screen, by the way. That might be helpful. And I will just rearrange Zoom because I want to see your faces too. Okay. So Gemnasium. Gemnasium, what is that? What do we do with it? So I will introduce a few concepts before diving into Gemnasium itself. You might have seen that it is an analyzer. It's an analyzer subgroup. So what is an analyzer? So you have here the secure and governed glossary link for our documentation. This will explain a few words that you might see repeatedly in the documentation or when we talk. That might be useful to familiarize yourself with that. If you have any doubt about one definition, raise a discussion because sometimes, like every doc, something can be outdated or might be worth improving. So feel free to do so. So what is an analyzer? Historically, GitLab has been working with security features based on either internal in-house scanners and third-party scanners. So in order to provide functionalities and integrated those third-party tools into GitLab, we created what we call the analyzers, which are projects that we maintain and that wraps around existing tools or other in-house tools. So this is the main distinction between an analyzer and a scanner. The analyzer is the tool we maintain that wraps around a scanner, and the scanner is basically the software that is capable of doing the scanning. So you basically can run the scanner on your own machine if you want, without having anything related to GitLab. If you run the analyzer, that's more about in the context of GitLab. So the scanner might be, for instance, Trivy, the app ESLint that's mentioned here. So Trivy is the one we use for container scanning. Gemnasium is a bit of both because you have the Gemnasium scanner that existed prior to joining GitLab, for instance, and not in that form, but that the principle is there. And then the analyzer, which is this Go project that we created to wrap the execution of the scanner, manage the integration with GitLab, deal with the inputs, the output, converting that to the correct format, for instance, to really fit into the whole GitLab Rails platform. So how do we integrate? By the way, feel free to interrupt me anytime if you have any question. I really don't mind. Or if you know better, or I say something wrong and you know about it, feel free to interrupt and correct me too. So how do we integrate that scanner, that analyzer in GitLab? There is a short video here that highlights how we used to do things, and I will just use the graph here as an example. You can look at the video if you want more details, but the TLDR is we use the CI job as a way to integrate our security scanning feature with GitLab because it's a constrained execution environment. We don't have to deal with a lot of things. We just say, hey, we want a container where we can run something and send the output to the Rails platform. So that's pretty handy. And what happens is we offer our customers to very simply add a configuration in their CI file by just including one line. So this is basically, where is the configuration gone? Configuration here. So this is basically leveraging what we call the CI templates, which you might have heard starting to be replaced by CI/CD components, which is a brand new kid in the block. But the CI templates have been there for a long time. And this is a way for us to provide an easy way to include existing CI configuration in a project one. So what that tells is if you have a CI YAML file, you just add this line here, and it instructs the CI to go look for that file, which is actually a file that we vendor into the Rails platform. So every GitLab instance in the world has those files bundled into their own files. So this is super handy. And they don't need to reach to gitlab.com, for instance, to get that definition. And they don't need to have to do some copy pasting and stuff like that.
Olivier, I have a quick question.
Yeah.
But in the graph you presented earlier,
Yeah.
that output seems to include advisory data. So it's not just purely dependencies, it's also vulnerabilities.
Yeah, that's how we are doing things historically and still a bit today. That's not the vision, and what you may have been pushed to dive into is more like just focusing on the SBOM, and that's the future. You're already ahead of us. And so, but right now, yes, we work with an output being the security scanning results. So the what was that saying? Yeah, just getting back. I wanted to share quickly a CI template to say you know what it is. So it's within the GitLab Rails code base. We have those templates here, for instance, for dependency scanning. And this is basically declaring some jobs. It's quite complicated because, well, it's been there for 6 years and we have been evolving that a lot. But the TL there is you have a job called dependency scanning for Gemnasium dependency scanning. That doesn't budge on things, but what it tells is please run this image, this Docker image, and execute a command. And then whatever is done after that, just upload the artifacts to the Rails platform. So the definition is quite complicated because there is a lot of reuse, a lot of composition here by using some hidden jobs for configuration and stuff like that. But the important part is we have an image that runs, we execute the command of the analyzer, and then we upload some artifacts that allows the Rails platform to access that information, This is what's showing up here. So what happens during a CI job scanning is, in the context of dependency scanning, is when the job starts, the runner does his usual things like mounting the repository, for instance, in the working dir, stuff like that. And then the analyzer will, on one hand, pull the advisory database, which is currently a Gemnasium repository in the context of the CI job. It's called the Gemnasium DB. So it's pulling the Git repository. There is a bundle version of it in the image, but it's still trying to pull it at runtime to make sure it gets fresh data. And on the other end, it will try to generate the list of component or the SBOM from the project repository. And once those two steps are completed, it does what I can say is the basic dependency scanning functionality, which is a matching between the component detected in your project and the known advisories we have in the database. And once it managed to do that matching and output the results in the correct format, it generates that report file that gets uploaded at the end of the process. This is, again, a very common and generic process. We declare that we want some files present at the end of the execution to be considered artifacts, and then the runner is doing its job itself. We don't have to do any upload ourselves, for instance. And once that's done, it's made available to the Rails backend. There are many things that happen there. I won't get into the details, but basically, Threat Insights group is responsible for ingesting that data, providing it to the correct features downstream in the Rails application, like the vulnerability dashboard, the merge request, that kind of things. One little thing that I want to make sure you're aware of, because that's a gotcha that is annoying to a lot of people at first, is the artifacts. There are multiple sorts of artifacts, and this is a bit silly because it's not straightforward at first. But here you can see we are declaring artifacts reports for dependency scanning. So we have mainly historically one type of artifacts, which was declared with path, which you can see here for the SBOM, for instance, which is like a random file. I mean, it's an arbitrary type of file. You can upload whatever you want. And there is no specific treatment for that, and it's made accessible in the UI. Like you can download those or browse them on the CI job page, for instance. You can download them via the API, etc., etc. And then later on, we introduced the report type of artifacts, because if we wanted to get access to these files in the Rails backend for some post-processing, we had an issue with the way the original artifacts were uploaded and stored, apparently, if I recall correctly. So we introduced this kind of reports artifacts, and those unfortunately don't benefit from the same feature in the downstream processes in the race platform. So you might not see them, for instance, in the CI job page. Some might be available in some API endpoints. It's really mix and matches. It's not great experience, unfortunately, so far. There is a lot of technical depth around those. But for our usage, main usage, it works because this means from the REST backend, we can read those files, ingest the content, and store that in the database. But be careful when playing with artifacts and match the difference between path and reports. Obviously, there is some documentation around those, but I will let you dive into that.
Olivier, another question. The paths seem to have like a glob type of thing about them. So
Yeah.
what would be the values placed after dash -sbom?
It's because the way we generate this SBOM files, there could be some conflict. Like if you have a project that contains both a gemfile.log and a yarn.log, because you have like a Ruby gem backend and a front end in GS, you might have two log files. So you might have two SBOMs generated because the way we are doing things. And to avoid having a file name that will be have some concurrency issues, we need to add some specific matchers. Like I think the SBOM name is based with the package type or something like that. So we want a glob matching. We don't want to really declare everything, so we take advantage of the glob matching to say anything that is the form GL SBOM whatever .cdx.json. Consider that this is an artifact that you have to upload. So at the end, the runner will pick up everything that matches that glob and upload that individually.
Understood. So it doesn't drive logic when it comes to the Rails backend. It's just so we don't overwrite SBOMs with themselves, right?
Yeah. And
Right.
there was a lot of discussion around that. We came up at some point, I think, with a kind of a manifest. We still do. That's a part where I'm not so knowledgeable, unfortunately. But I think we had some issues because the way the SBOM format constraints didn't allow us to put many different types into the same CycloneDX SBOM report. So we had to generate different files, and then we had to find a way for the race backend to get that information back correctly. But yeah, it's a very more specific detail that I don't know, unfortunately. But interesting question to dive into if you want more details. All right, cool. So once that's done, then we say we leave that to the race backend for doing the downstream stuff. So let's go back into what really happens in Gemnasium then. So I said this is a Golang project. It's released as a Docker image to be executed into the context of a CI job. And it's following some kind of framework. You might heard about what's called the common library, which is not so used anymore because it's been deprecated in favor of more specific Go packages. It's written there. So because we have the same needs about wrapping a scanner with some log management, conversion of a proprietary report output into the common one we use and want to send to the race platform, we had a common need between all the different analyzers and different teams later. So it was interesting to come up with some common packages to handle that. So that's what these little utilities are made for. And this basically is shared with static analysis. Dynamic analysis, not so sure because they don't use Golang as much as I know. Maybe the new Brother project does. But yeah, so this is those are shared components. Feel free to look at them, contribute to them, and become a maintainer of them if you'd like. That's more than welcome. So one complicated thing that you might want to know about Gemnasium, because an analyzer is not like a very complicated piece of software. It's basically dealing with inputs, outputs, executing the underlying scanner, and that's it. That's not really very fancy logic in there at first. But with time, obviously, Gemnasium has become a much more complicated project. And the first thing that is important to notify is it's a merge of three separate projects. So going back to the template, you may see that we declared 3 different jobs. So when there is no dot, prefix dot on the job name, it's kind of a real job that will actually be executed. The dot or one are hidden, and they are more used for inheritance composition or that kind of thing. So Gemnasium dependency scanning is the basic one. Then you have Gemnasium Maven dependency scanning, and then you have Gemnasium Python dependency scanning. And then you have some very deprecated ones that no longer run. These were other third-party scanners that we were running, but no longer does. But for backward compatibility, we left the job there to avoid breaking the pipeline. Anyway, those will be gone in 17.0. So why do we have 3 different analyzer? Because 3 different, job and underlying analyzer, underlying images. It's because doing dependency scanning, as I mentioned initially, is about getting the list of component on one hand and getting the list of advisories. The advisories part is common with all the different projects, but extracting the list of components from a given project might involve different approaches depending on the project itself. I mean, the language or the package manager that is being using. So the TL there it's pretty straightforward for a lot of languages and package manager that provides a log file. And as you can see, this is a rule that exists if that tells if one of those files exists, please trigger the job. And that's what is being used for triggering the main Gemnasium dependency scanning job. Anytime you have a log file, it's super straightforward. We just have to read, parse that file, and extract the list of components, because from there we know exactly what package type, what package name, and what package version you are exactly using in your project. So we don't need to run any command to get the what is really used by your project as a dependency. And so that's why all those technologies are handled into the same project, because it's pretty straightforward. You have in the Gemnasium, oh no, builder is not the right one. So sorry, that might be more in the scanner parser. So you will get parsers for a ton of different type of files. So if I go into gem file, so you got the gem file parser here, which will be looking at the gemfile.log file and extract the dependencies from there with, well, the specific syntax matching that is necessary for that file. And on the other hand, for Maven, and not just Maven, actually, it's more Java, but it started with Maven, hence the name. And then, well, it's complicated to change names afterward because breaking change and stuff like that. So it stayed with Maven, but this is basically handling a lot of other files in the Maven, in the Java ecosystem. So you can see here, anytime there's a pod XML or a build, a Gradle file or SBT file, it will trigger that job. And so Gemnasium Maven is for Gemnasium Maven scanning. So this is necessary because we need to execute some package manager commands, like for POM XML, we don't have the specific version, and we don't have any dependency resolution results in a file. We have to run Maven cycle to extract that. And that's why we need all the Java ecosystem, the environment, to be able to execute the project. And since this is coming with a lot of additional resources, I mean, that image is probably 1.6 gigabytes, something like that. That's pretty annoying because anytime a job is running, that image is pulled. So that's really annoying to mix everything in the same image. So that's why we separated for that one. And same thing for Python. There are some log files for Python, so it's more like a more nuanced, I'd say, situation for Python. But because it's complicated, it's simpler because dealing with Python project is complicated. It's simpler from our perspective to leave all the Python related logic into the Gemnasium Python analyzer. So that's why even if it's about some log files, it's supposed to be handled by the Gemnasium Python analyzer. Does that make sense so far?
Do you know, just one question, do we know how common the log files actually are? So you wouldn't necessarily have to have a requirements, a poetry log file. It's something that sometimes just happens when you build a project, and it just kind of temporarily exists, but it's not committed to the repository, right? So how common do we think this happens? Do we have any statistics on that? Maybe John knows.
It's hard to tell. Most of our, I mean, it depends if you're talking about the community in general, where we can get like outside source of data for that. But when it comes to our own customer, it's really difficult to get data because most of our customers are ultimate customers, self-managed customers, sometimes offline customers, which means we don't have any telemetry for them. We have very, very few customers that enable the telemetry like them. The call service ping that just send data there, they don't like it, they disable it, so we have very limited visibility on that. What we get is most of the feedback we're getting is via the customer the sales account or the support channels where people say, well, I'm using that project, it doesn't work. So that's mainly where we get our feedback about usage. And unfortunately, Python is quite complicated, and things could be very simple. Like if you're using Poetry, for instance, it's straightforward. It's as easy as with npm.js or with the gem files, for instance. But most of the enterprise level customers use some very complicated build system using requirements file, and the underlying issue is requirements. The requirements file can take many names. So the name of the file can be different. They use a lot of different conventions. I don't know if we can say conventions because if nobody is following the same one, it's no longer a convention. So there are many different usages in the Python world about how we name that file and what its content is. So what I learned recently, because I'm not a Python expert, is actually the requirements.txt file can be used as a log file, depending on what package manager you were using with Python. And there is an issue about checking that and considering the requirements file as a log file rather than trying to rebuild and install the dependencies. But yeah, that's one of the difficulties of dealing with those not so clear ecosystems, not so clear package managers. So one side effect of that is we have to build 3 different images, which is a huge part of the complexity of the build pipeline of the Gemnasium project, for instance. It used to be 3 different separate projects. So you might see there is a Gemnasium Maven project that is archived right now. So some codes used to be there, but we realized that because they were sharing so many different components, and for whatever reason, Fabian might tell you more about that, it was easier for us to put everything into the same project. But that means more complicated build process, obviously. So here we have some directory specific, forget about sbumgen, please. Just consider this line doesn't exist. I don't want to explain that and dive into the details. It doesn't exist. But basically, Gemnasium every image has 2 variants because we support FIPS compatible, FIPS compliant variants for our FedRAMP customers. So basically, we try to either use Alpine or maybe Debian, depending on the needs of the underlying scanner and the underlying project we want to support with that scanner. And if this is for FedRAMP compliance, we use Red Hat. It's mostly based on the UBI8 minimal. Where are you? Yeah, here, UBI minimal. So we have the Docker files. We might have also some specific helpers. I don't recall. Yeah, for Gemnasium Maven, we have to install some additional plugins. So for Gradle, Maven, SBT, yeah, there's a lot of fun to dive into there. If you have the opportunity, you will love that. I can tell you because I did it recently. But the overall idea is these files help building specific images. And what that creates is this mammoth of a pipeline. Can we have something on master here? I might try to make my screen a bit bigger. I don't know if that works well for you. Let me know otherwise. So a lot of things happens here. So there are jobs that runs in the context of that repository in this main parent pipeline. And then we trigger child pipeline. And we trigger child pipeline in the same project. It's an inception, basically. So for each of the image we want to build, we trigger another pipeline. So that's why you see, oh, sorry, it's called trigger job, because this job itself doesn't do nothing. It tells the CI to run another pipeline. And this is running another pipeline in the context of the Gemnasium project for building the main Gemnasium image. So it builds the image, the FIP variants, do some various tests, trigger some downstream pipelines, which are child pipelines on another project. And this is what we use for testing some kind of testing. We try to limit this because they are painful to deal with, and we've tried to replace that with what we call image tests instead. But if you see that, it's basically, again, trigger job. It's telling run a pipeline on the GS and PM project. And this is what's happening there. And it runs the Gemnasium dependency scanning job, which is the usual one we do run for the dependency scanning analysis, and then do some additional checks to verify that the output is as expected. So that's why you have all those different pipelines. If you are working on a single analyzer, you can use a tag, a label, sorry, where are my merge requests? Here they are. You can have one, you can use, oh yeah, sorry, this one I had it. So you can see here, trigger Gemnasium Maven, that instruct the CI to only run the pipeline for the Gemnasium Maven. That helps speeding things up, particularly if you're not working on Maven, because Maven takes ages to build. The image to build Maven is nearly an hour to build. So you can see there is just that one running here. We're getting out of time. Is there anything else I could talk about? I don't see anything else in my notes, at least. Do you have any question?
I'd be happy to get some sort of, well, I don't know if there's documentation, but any sort of explanation about the actual flow of what is happening within Gemnasium when it runs. Like, what are the steps that it takes?
Yeah, so that will be more of a walkthrough of the project itself, which
Mhm.
I would definitely not be the best person to do that because I'm not so familiar with the code base itself. Again, I'm good at telling you the high level things, but the code is not that difficult to read though. So depending on how familiar you are with Go, the process is not so complicated. There are some obviously some little things. Where is the main? Oh yeah, no, that's getting more complicated because of the fact that we have multiple packages, so we don't have the same functions for each. So that's what's complicated this project. The main is kind of eaten into a sub package, but we have a CLI command that calls many different steps, and you can even call individually. So looking at the CLI command, that might tells you what are the different functions that can be called. But yeah, I think the scanner would be the right one. Anyway, that's a good question. I won't do it right now, but that's maybe a good use case for another short video about that. Anything else? There was some questions above. Sorry, I didn't saw that. Oh no, okay, interesting points. Thanks. Thanks for typing those notes, whoever it was. Appreciated. Yeah, thanks, Yutal.
Thank you, Olivier. This was really, really helpful. We will probably see if we can maybe schedule a quick walkthrough. We'll see who's the right person for that. It was very informative, so thank you very much. And I think we should cut it here so everybody has time.
Yeah.
Thank you a lot, Olivier. Thank you, everybody who was listening. Have a good day.
Have a good day, everyone.
Thank you. Have a nice day.
Bye, France.